Hi guys, this is Mrs. Allison, and we have been putting together some videos for you, and this one I want to use to clarify some of the things that you should have learned yesterday. One of the things that I don't think was detailed as much as it should have been was the use of your calculators. And so I want to look at the calculators with you. So you may have had slightly different answers than your neighbors. They may look weird compared to maybe the answer key. So I want to look at that. There are two types of calculators that you can find. There is a graphing type that you would see here on the left. Yours may look fancier than this one. Yours may be the nice pretty color one. Yours could be a TI-83, which is a little bit different. But all graphing calculators are going to be primarily the same. And then there's a scientific calculator. Now, I happen to have a TI scientific calculator. If you're using something different, it will look a little bit different. But we need to make sure your calculator is in the correct mode. So here's what that's going to look like. On the graphing calculator, what we're going to do is we're going to turn it on. Let's turn it on first. And then what we're going to do is we're going to push the mode button up here at the top. And we want to go down to where it says radian and degree, and we want to highlight or make sure that degree is highlighted, and when it is, we hit enter. So it should be in degree mode now, and we can quit out of it by hitting second quit. Now in the scientific calculator, when we turn this on, what you'll see up at the top of the screen is this little DEG. If that's not there, what you need to do is push the DRG button. There's degree, radian, and GRD, which I'm not actually sure what that is. We want degree. So we're going to make sure degree is underlined, and then we're going to hit the enter button or the equal button. And now your calculator is in the correct mode. So now let's look at an example from yesterday and do a little bit of review. Okay, so we're going to do a little bit of review of our trig ratios. Hopefully from yesterday you remember that our trig ratios, there's three trig ratios. There is the sine, and I'm going to write this on here, which is abbreviated SIN, not sin, and it's the sine of an angle equals, and we typically use theta to represent an angle. You could use x, it means the same thing, equals the opposite over the hypotenuse. We have then the cosine of theta, which equals the adjacent over the hypotenuse. So we'll just write that in here, ADJ, we're going to abbreviate it. Sorry, I'm writing on an iPad, it's a little bit hard to do. Adjacent over hypotenuse. And then finally we have our last trig ratio, which is the tangent. And the tangent of theta equals the opposite over the adjacent. Okay, so those are our three trig ratios, and what we learned yesterday is there's a nice mnemonic device that we can use that is called Sohcahtoa. So the easiest way to remember that, the trig ratios, is by Sohcahtoa. Okay, so let's talk about Sohcahtoa. Well, it doesn't even look like an S. Got worse. Okay, so let's just look at it. That's an O, by the way. The sine stands for the opposite over the hypotenuse. The cosine stands for the adjacent over the hypotenuse. And the tangent stands for the opposite over the adjacent. So let's look at an example. Let's say I have a triangle, and remember trig is used with right triangles for right now. So let's say that I have a triangle that looks like this. We know it's a right triangle, and we know this side is 15. We know this side is going to be called x, and then this angle right in here is going to be 35 degrees. So I'm going to write that on the outside because I'm never going to make it on the inside. 35 degrees. So how do we use Sohcahtoa? What we're going to do is we are going to look at the angle. So if this is our angle and this is 35, we want to see what is across from it. And what I see that is across from it is an opposite. So I'm going to label that. I'm going to label that my opposite by just putting OP PP, opposite. And then what I see is that next to my angle is this 15. Why do we know that this is not the hypotenuse? Why do we know that this has to be the adjacent and not the hypotenuse? Well, the hypotenuse will always be across from the 90 degrees. That little angle mark will always point to my hypotenuse. So here's what I know. I have the opposite, I have the adjacent, or I'm trying to find the opposite, I have the adjacent. So the trig ratio that uses opposite and adjacent is tangent. So now we need to set up an equation, and the equation is going to look like this. Tangent of the angle equals opposite over the adjacent. So here's what that trig ratio looks like. I am going to say the tangent of the angle, and the angle we know is 35 degrees. It doesn't like the degree mark. Equals the opposite, and the opposite for this one is x over the adjacent, which is 15. Now, if I want to solve this, if I want to figure out what x equals, I need to undo the 15 from both sides. So I'm going to multiply both sides by 15. So what it looks like when I write this equation is it looks like 15 times the tangent of 35 degrees, that's the angle, equals x. Now, there are two ways that we could plug it into our calculator. So watch this video up above. You can see the first way is we just hit the tangent button and then do the tangent of 35 and hit enter. And then we can multiply it by 15, which gives us an answer of 10.5. Or we can type it straight into our calculator as 15 times the tangent of 35. Gives us the same answer. And on the scientific calculator, it looks the exact same. So 15 times the tangent of 35, hit enter, and we get our answer of 10.5. Okay, so we know that this side is 10.5 roughly. So that's the side x, that's this opposite side here, is roughly 10.5. All right, so now we're going to move on to our new lesson.